Wind energy. Today's wind turbines are capable of converting a great amount of energy in the wind into electricity. This is due to the blades, which are developed using state-of-the-art aerodynamic analysis and the other performance-enhancing equipments. If the blowing wind can turn the wings, we will receive electricity from the generator that is attached to it. However, how does the blowing wind turn the wing? Let's have a close look at the blade. The blade has a lot of airfoil cross-sections consisting of different sizes and shapes from the root to tip. The simple airfoil technology makes the wind turbine blade to turn. That means that a lift force is produced when a fluid moves over an airfoil. This way the wind turbine achieves the basic rotation which we are accustomed to seeing. Note: just as in a moving train, you experience things relatively, similarly the moving wind turbine blade also experiences the wind relatively. For the moving blade, the relative wind velocity is as shown below. Therefore the wind turbine blade is positioned in a tilted manner in order to align with the relative wind speed. As the blade velocity increases to the tip, the relative wind speed becomes more inclined towards the tip. This means that a continuous twist is given to the blade from the root to tip. However, this rotation cannot be directly coupled to a generator. Note: the wind turbine blades typically turn at a very low rate of RPM due to the issues of the noise and mechanical strength. Considering this low speed of rotation, we cannot produce any meaningful electricity frequency from a generator. So before connecting to the generator, the speed is increased through gearbox. The gearbox uses a planetary gear set arrangement to achieve high speed ratio. A brake is also attached at the end of gearbox. Note: the function of the brake is to arrest wind blade rotation during excessively windy conditions. The housing holding the gearbox and generator is called nacelle, which can move according to the direction of the wind. If the direction of the wind changes, then velocity sensor located on the top of the nacelle sends the electronic signal to the yawing mechanism at the base of the nacelle. This moves the blades in proper wind direction for the maximum power extraction. Also, blades can rotate using blade tilting mechanism to align itself to the proper angle of the wind direction. Consequently, the electricity that is produced passes through the cables towards the base where a step-up transformer is situated. In this way, wind turbines can convert wind energy into electricity. Note: there is a theoretically maximum efficiency a wind turbine can achieve. This limit is known as Bitz's limit. Essentially, it means that no wind turbine in the world can ever cross the efficiency limit of 59.3%.